Our summary slide, the question asks, what did we learn in the previous chapter? So please think about what we learned back in chapter 3 and try to come up with some ideas. You can always look back at your notes if you don't remember. 4.1, our learning target says I can graph a line to represent a linear equation. And our essential question says, how do you graph an equation written in slope-intercept form? We've worked with slope-intercept form before. It was written in function notation in chapter 3 like this. So we are just making a tiny little adjustment and writing our slope-intercept form like this instead of in function notation. Function notation, f of x, and using the variable y, they're interchangeable. Okay, so our equations in this chapter, we are going to write in slope-intercept form using y equals mx plus b. So remember that m represents the slope of the line, or the rate of change. And we've learned multiple ways to find the slope or the rate of change for a line. So hopefully you remember these things. We said the slope could be rise over run. If you're looking at a graph, I would always count rise over run. We also said from a table, you could find the change in y and divide it by the change in x. And then last, we had that slope formula for ordered pairs, where you would substitute and subtract your two y coordinates on the top of the fraction and subtract the two x coordinates on the bottom. So rise over run, I used for finding the slope or rate of change from a graph. Change in y over change in x from a table, and then the formula from ordered pairs. So that's a lot of review from chapter 3 right there. Okay, so y equals mx plus b. M is the slope of the line, and b is the y-intercept, which is where your graph crosses the y-axis. So where the line crosses the y-axis. Okay, so lots of information here. So the two important things are the m being your slope and then b being your y-intercept. So just to kind of make sure, we're going to highlight those so that you make sure you know the importance. Okay, on our y slide, it says back then we found rates of change and slopes. Now we're going to write and graph linear equations in slope-intercept form and model real-world data with equations in slope-intercept form. Why? Jamil has 500 songs on his digital media player, or for you on your phone. He joins a music club that lets him download 30 songs per month for a monthly fee. So maybe it's Spotify or something like that. The number of songs that Jamil could eventually have in his player if he doesn't delete any songs is represented by this equation, y equals 30x plus 500. So what's significant here is the 500 songs that he started with. You notice that doesn't have a variable. That was his starting point, which is his intercept. And then the rate that it's changing is 30 per month. That's the slope. That's the rate of change, how much it's changing. And that's the one that gets the variable because x would represent each month. So 30 times however many months, and then plus 500 songs that he started with would be an equation for any point in time. All right, so now we're going to start out by writing an equation. So y equals mx plus b. I need my slope and my intercept. So I'm looking at a graph. So that means rise over run. Remember that you are starting at the point on the left. This is super important. Read your slope from left to right. So starting at this dot on the left and traveling to the next dot over on the right, I go down 3 and then I go over 2. So what that means is -3 over 2 is the slope of my line. So y equals -3 over 2x plus the y-intercept. I'm going to highlight for you. So here's my highlighter. The y-intercept is right here. It's where your graph crosses the y-axis. So if I count from the origin, that point is up 1, 2, 3, 4, 5. So plus 5. So starting at the origin, the middle of the graph, the y-intercept is up 5, so +5. Next one, same thing. So slope-intercept form, I need my slope and my intercept. Now, when there's 3 points on your graph, it doesn't really matter which one you start with. On the left, I'm going to start with like the furthest to the left right here, and then I'm going to end at the origin. So remember, it's rise over run, and you're going left to right. So I could start at either of those 2 points because there were 3. So I start here, I go up 1, 2, 3, 4, and then I go over 1. Up 4, over 1. So 4 divided by 1 is 4. And this time, my y-intercept, where the line crosses the y-axis, is at 0 right here. So you don't have to write anything. You don't have to put a +0. It's most often just going to be y equals 4x. Okay, so when the intercept is 0, you don't need to write a 0 there. Next one, slope-intercept form. Well, y equals mx plus b. This one doesn't have a slope because horizontal lines have no slope. So this time my slope is 0. So if you look at an equation like this, 0 times x, and then plus my intercept, I'm going to highlight my intercept. My intercept right here is -1, 2, 3. So -3. So I'm going to clean this one up. So 0 times x is 0. So I'm not going to write that. And then the intercept is -3. So it's simply y equals -3. That's the best way to write an equation for that line. We don't want 2 signs in a row. So we don't want plus a -3. And when the slope is 0, you won't see an x in your equation at all. All right, now you might be wondering, so that was a horizontal line, this one's vertical. Well, a vertical line has a slope that's undefined. So the slope is undefined this time, so we can't write an equation in slope-intercept form. What this line has is only an x-intercept. So the x-intercept is right here at 3. So the equation for this entire line is x equals 3. So horizontal lines have equations with only a y in them, like this one. Vertical lines have an equation with only an x in them. Okay? Because the slope is undefined for a vertical line. Okay, now we're going to do a little reversing here. This problem tells you the slope and tells you the intercept. You have to write your equation in slope-intercept form and draw a graph. So I'm just going to go like this. My slope is -1. My intercept is 5. When you graph, make sure you're graphing the y-intercept first. So graph the y-intercept. This one is 5. So put it on your y-axis. Then you're going to make the slope a fraction. and use it to find 2 more points. So the slope this time is -1. So that means -1 over 1. So rise over run. If the rise is a -1, I actually have to go down 1. And then my run, I always go over to the right. Because remember, we're left to right. Down 1 over 1. And then I can draw my line. So graph the y-intercept and then make the slope a fraction and use it. Okay, next one, y equals my slope 2/5, then the x, and the intercept -3. So start at that -3, and this time, rise over run, it's already a fraction. So I rise 2, so I go up 2, I run 5, over 5 to the right. Rise 2, run 5. You want 3 points on your line. 3 points. Next, we have to do a little rewriting. This is not in slope-intercept form. So if I highlight my variable, y, because slope-intercept is y equals mx plus b, we want the y by itself. So I would have to subtract 3x to move it over to the other side like this. So y equals -3x plus 6. Look at the order that I wrote those in. So to get y by itself, subtract the 3x to cancel it out. But then the order is super picky because you want it in slope-intercept form. So don't write 6 minus 3x. And remember, those aren't like terms. So you can't actually combine them. So the intercept to start out is 6. And then the slope is -3 or -3 over 1. So I need to go down 3 over 1. Down 3 over 1. Like that. So the rewriting piece is back in chapter 2. We learned how to rewrite. So, and we're trying to get these into slope-intercept form. So we're always solving for the letter y. It's just rewriting it from standard form and turning it into slope-intercept because that's an easy form to graph. So subtract 6x. It's on the wrong side. Bring down your -4y. Write these in order, slope-intercept order. -6x first plus 12. And then there's one more step this time because here's my y. So I need to divide to cancel the -4 and divide each of these by -4 as well. So simplifying my fraction, -6 over -4 reduces to 3 over 2. 3 over 2. And then 12 divided by -4 is -3. Remember on this fraction, when you divide a negative by a negative, it's a positive. So my graph needs to start at -3. And then my slope says rise 3, run 2. Rise 3, run 2. So there's my graph. Okay, last two. Y equals -3. Remember on the y-axis, -3 is right here. There's my line. If it's only got a y in it, it's a horizontal line. And if it's only got an x in it, on the x-axis, here's 2, it's a vertical line. I think those are the trickiest ones to remember, the horizontal and vertical ones. Okay, now we've got a word problem, and I'm running out of time on my video. 2 word problems left. I'm going to do a separate video for the 2 word problems.